Hi guys, I'm JED Abolino, 11 Mendel from Rizal National Science High School, and today we're going to talk about solving systems of nonlinear equations. We're gonna jump right into the topic. System of nonlinear equations, also known as SNE. It is a system in which at least one of the equations is not linear and has a solution set. An acronym for solution set is SS. A solution set of the system is the set of point P, x, y that will make all the equations in the system true. So the solution set is the point where the two equations meet. On solving SNEs, I have two tips for you. First tip is knowing the equations involved. In a system of nonlinear equations, there are types of equations. First is linear equation, which has a general equation of ax plus by plus c is equal to 0, and an slope-intercept form which is y is equal to mx plus b. And the other equations involved are conic sections. First, circle. Circle has a standard form of x minus h squared plus y minus k squared is equal to r squared, and a general form of ax squared plus by squared plus cx plus dy plus f is equal to 0, where a and b is not equal to 0, and they are both equal. The ellipse has a standard equation of x minus h squared over a squared plus y minus k over b squared is equal to 1, or x minus h squared over b squared plus y minus k squared over a squared is equal to 1. And a general term of ax squared plus by squared plus cx plus dy plus f is equal to 0, where a is not equal to b and they are both not equal to 0. The parabola has a standard equation of y minus k squared is equal to plus minus 4c times x minus h, or x minus h squared is equal to plus minus 4c times y minus k. The general form of parabola is ax squared plus by squared plus cx plus dy plus f is equal to 0, where a or b is equal to 0. And lastly, hyperbola. The hyperbola has a standard form of x minus h squared over a squared minus y minus k squared over b squared is equal to 1, or y minus k squared over a squared minus x minus h over b squared. The general form is ax squared minus by squared plus cx minus dy plus f is equal to 0, or negative ax squared plus by squared minus cx plus dy plus f is equal to 0, where a is not equal to b and they are both not equal to 0. Second and last tip, combinations. The combinations of two equations could be linear with any conic section. This has at least 0 or at most 2 solution sets, while two conic sections will have at least 0 or at most 4 solution sets. There are three methods of solving system of nonlinear equations. First, graphical method. Second, substitution method. And lastly, elimination method. In graphical method, we graph the equation and see wherever they met. Here, I graph 3 lines and then one parabolic equation. The first line has a negative slope and doesn't met the parabolic equation. So this means there is no solution set between the two. While this horizontal line or constant function has had met with the parabolic equation with one point and which is the vertex. And the last line with positive slope, they met with 2 points which is negative 2, 0 and 3, 5, so they have two solution sets. In solving using the substitution method, we have two equations, of course. First given is y is equal to x minus 3, which is a linear equation, and the second, x squared plus y squared is equal to 17, which is a circle. So the possible number of solution sets they have will be 0 to 2. Substituting 1 to 2 makes x squared plus the quantity of negative x minus 3 squared is equal to 17. Then, squaring the binomial, we have x squared plus x squared plus 6x plus 9 minus 17, which the 17 in the right side we transpose to the left side is equal to 0. Then we simplify 2x squared plus 6x minus 8 is equal to 0. Then we use GCMF, we divide the left side with 2 to have 2 times the quantity of x squared plus 3x minus 4 is equal to 0. We factor the trinomial and we got 2 times the quantity of x plus 4 times the quantity of x minus 1 is equal to 0. We equate the two binomials to have the value of x. First, we have x plus 4 is equal to 0 when transpose is equal to x equals to negative 4. While the x minus 1 equals 0 when transpose x is equal to 1. Substituting x is equal to negative 4 and 1 to first or second equations, which I prefer the first equation because it's not more complex other than the second equation. So, we have y is equal to times negative times negative 4 minus 3, which we arrive at the answer y is equal to 1. And then the other side, x is equal to 1, we substitute it to the first equation as well. We have y is equal to negative 1 minus 3, and then arrive with y is equal to negative 4. So the solution set that satisfies the two equations are negative 4, 1 and 1, negative 4. The difference between substitution method and elimination method is that the first method, the first part of these methods, in the substitution method, we substituted first, while in the elimination method, we first eliminate a part of the equation and then we substitute at the last part. So here we are. Elimination method. The first equation is an ellipse which 3x squared plus 2y squared is equal to 35, while the second equation, hyperbola, is 4x squared minus 3y squared is equal to 24. The possible number of solutions to both conic sections are 0 to 4. To eliminate a part of any in the equation, we try to make the same part in both equations the same and then minus or plus them to eliminate that and arrive for either x or y values. So the first equation, I times it with 3 to have 9x squared plus 6y squared is equal to 105, and the second equation, I multiplied it by 2, which then arrived to 8x squared minus 6y squared is equal to 48. Adding both equations will have 9x squared plus 6y squared is equal to 105 plus 8x squared minus 6y squared is equal to 48. We will then eliminate y squared because they have both 6 in their constant and the other is negative and the other one is positive. So, we arrive at 17x squared is equal to 153. We divide both sides with 17 to have x squared is equal to 9. And to have x, we should square root both sides to have x is equal to plus minus 3. Substituting x is equal to plus minus 3 to any equation, and I chose first equation, so we arrive with x having x value negative 3. We arrive at 3 times the quantity of negative 3 squared plus 2y squared is equal to 35. And then simplify the square in the parentheses, we have 3 times 9 plus 2y squared is equal to 35. And then simplifying again, 27 plus 2y squared is equal to 35. Transposing 27 to 35, we have 2y is equal to 35 minus 27. And then 2y squared is equal to 8. Dividing both sides with 2, we'll have y squared is equal to 4 and square root we need to square it both sides to have y, and we'll arrive with y value plus minus 2. The the other x value, which is 3, we will then substitute to the first equation. We have 3 times 3 squared plus 2y squared is equal to 35. Simplifying the parenthesis with exponent, 3 times 9 plus 2y squared is equal to 35. Then simplifying, 27 plus 2y squared is equal to 35, just like this part. So we'll have 2y squared is equal to 35 minus 27. Simplifying again, 2y squared is equal to 8. Then dividing both sides by 2, we arrive at y squared is equal to 4. Then to have the y value, we square root both sides. So we have y is equal to plus minus 2. The solution set we will have are negative 3, negative 2, negative 3, 2, 3, negative 2, and 3, 2. That's it for today, guys. I hope you learned about solving nonlinear equations. Again, I am JED C Abolino representing 11 Mendel from Rizal National Science High School, signing out. Peace!